Welcome, everyone. On behalf of the team at MultiX, we are excited to invite you to this demonstration of our latest advancements in localized intelligence. Today, we'll be showcasing a deep dive into robotic tracking capabilities, specifically focusing on how we leverage the synergy between 5G and Wi-Fi passive sensing. At the heart of the MultiX vision is a comprehensive fusion system integrated directly within the 5G network. As you can see on the left, we capture data from a wide range of sensing sources, ranging from fast-moving targets like drones to slower objects like pedestrians. To process this, our system harmonizes four critical pillars: a unified ISAC channel, a multi-band approach, a multi-technology framework, and multi-static sensing. By integrating these diverse inputs, the MultiX perception system uses energy-efficient AI to transform raw signals into actionable intelligence. Finally, this data is centralized within the dash management system, providing a seamless flow from the physical environment to a unified digital dashboard. Moving into the system architecture, the MultiX blueprint is structured around three primary pillars. First, at the top left, we have the MP6RC, our RAN orchestration engine. This controller manages the coordination between diverse hardware, including 3GPP and Wi-Fi, to abstract complex data into a unified interface. Below that, the MultiX perception system, or MPS, represents the physical layer. This is where the actual sensing occurs across 3GPP and non-3GPP technologies, like LiDAR and cameras, all powered by embedded perception functions. Finally, on the right, the dash and core domain handle the heavy lifting: distributed analytics, secure storage, and the high-level orchestration of sensing services. This entire ecosystem is tied together by centralized control and data buses, ensuring seamless communication across the network. To bring these concepts to life, we've developed a functional proof of concept, which you see pictured here in our lab environment. We have deployed several of our key MultiX components on top of an OpenAirInterface 5G network. Looking at the setup, you can see the strategic placement of the GNB and Wi-Fi access points serving as our primary signal sources. We've established a dedicated tracking zone grid, highlighted in the top right photo, where our 𝗂𝗀𝗶𝗴𝗃 operate. The diagram below illustrates how we've mapped our sensing control and data planes directly onto the OAI framework, allowing us to validate real-time tracking of robots within a live 5G-enabled environment. As we begin the demonstration, we start with the physical infrastructure of our 5G testbed. You are looking at the GNB, implemented here as a 5G dot, operating on N78. This serves as our primary signal source for the sensing environment. As we walk through the lab, notice the distributed USRPs positioned at various points. These units are the ears of our system. They act as passive receivers representing the user equipment, a mobile phone that captures the reflections of the 5G and Wi-Fi signals. This setup is built on top of the OpenAirInterface framework, allowing us to map the sensing control and data planes directly onto a real-world 5G stack. Now, the demonstration begins in earnest as the robot starts to move across the tracking zone grid. If you look at the top right of the screen, you'll see our digital twin in action. The digital twin is a near real-time replication of the robot's behavior, powered by our MultiX perception system. As the robot navigates the environment, the system processes raw sensing measurements from the USRPs and updates the DT near instantaneously. This shows the precision of our multi-static sensing and the efficiency of our AI-driven processing, which transforms radio signal fluctuations into precise spatial coordinates. This testbed serves as a practical realization of the MultiX blueprint. A key technical milestone of this demonstration is that we have implemented our framework on top of the 5G core of the OpenAirInterface. By leveraging the OAI 5GC, we've successfully integrated heterogeneous sensing sources, including both 3GPP and non-3GPP technologies like Wi-Fi, directly into the 5G network architecture. This creates a tangible framework for what we envision as native 6G intelligence. One of the standout achievements shown here is the centralization of sensing data within our dash management system. This infrastructure allows for secure, distributed analytics and data storage, ensuring that the tracking intelligence can be exposed to third-party applications safely and efficiently. By combining energy-efficient AI, we are proving that sensing can become a native, low-power feature of future networks. Ultimately, this demonstration confirms our ability to accurately track targets in complex environments, paving the way for advanced industrial automation and smart urban sensing applications. Thank you very much for your time and interest in the MultiX project. We invite you to stay updated on our latest developments by following us on social media. Simply scan the QR code you see on the screen to connect with us. We look forward to shaping the future of 6G sensing together.